Probably the most difficult of these four topics, the stretches, compressions, and different shifts, is the concept of phase shift and horizontal shift, and how they interplay with what we change the period of the function to be. So the way this is usually written is f of x equals sine of omega x minus capital C. It could easily be cosine as well, where capital C is called the phase shift. Now C is always relative to 2 pi, so C equals pi would be completely out of phase regardless of what you use for the period constant. Let's take a look at that. Here we are in Desmos, where I have sine of omega x, which is an unshifted function with a possible different period depending on my value of omega. And here I have g, which has a shift in it. So now my period constant here is 1. So as I start increasing the value of c, you notice that these go from overlapping completely to not overlapping much, and then eventually when c equals 3.14159526535389793, they are completely what you say out of phase. The value of this and their being out of phase does not depend on the period. Whatever the period is, as long as c is pi, these functions are going to be exactly out of phase. In phase or out of phase is very important because when we add waveforms together, interesting things happen. In Desmos, you can just call this one f, call this one g, and then plot f plus g here. When they're exactly in phase and you add them together, the resulting waveform is larger than either one put together, which kind of makes sense because if this one is 1 and the other one is 1, then 1 plus 1 is 2. But watch what happens when I start sliding them out of phase. The combined waveform, the purple one, is no longer larger. In fact, at some point, they start canceling each other out. So the blue and the red waves here, having different phases, means when you add them together, they kind of cancel each other out a little bit, until eventually, if you're at pi, the resulting wave is completely canceled out. So think something like noise-canceling headphones when you think about something like that, but it also has implications for electrical engineering. The other way to write this is f of x equals sine of omega factored out of x minus capital C over omega, and then two closing sets of parentheses. Now, C over omega, we don't have a special symbol for this, but this calculation is the horizontal shift. So this is the actual amount you see on the graph. For example, 2 units to the right. For example, if g of x equals sine of 5x minus pi over 3, identify the phase shift. We can do that pretty simply because the phase shift is c. That's the number we're subtracting from our x term in the sine function. So in this case, c equals pi over 3. Identify the horizontal shift. This is where we calculate from our equation that omega equals 5. So c over omega is pi over 3 over 5, which then we just make that over 1, do the usual thing where we multiply that by 1 over 5 times 1 over 5. C equals pi over 15. So let's plot this. So we entered this, but let's change our x scale here so we can see this a little better. So you notice this sine wave here is unshifted. It starts at the midline going up. This one is shifted over. It looks like if we just took this blue line and shifted it over to the right, we would get the green line. Well, how much did we shift it over to the right? Well, pi over 3 is the phase shift, but in terms of the total number of units you shifted it over, it went from 0 to pi over 15. Pi over 15 is about 0.21. So the green is the blue that shifted about 0.21 units over. The thing is, this is a lot to take in. It's a lot to memorize. I don't really memorize it myself. I just look it up when I need it. So this is where you're going to want to have your page of notes or something that you can refer back to when you need to do these calculations. If you think this is supposed to be obvious and you're supposed to get it right away, I've taught math 112 and 111 a lot, and I can assure you this is not. I had to review it just to put these notes together. It makes sense, but it's kind of hard to see. So just go back to your notes. The concept of phase shift is in the book in section 5.6, but the powers that be decided that that was not a good way for you to learn the material. They preferred different notation. So you're going to notice there's no My Lab Math section for 5.6. In fact, there's no homework on this at all, or the quizzes. It might show up on a test, but otherwise just be aware that it's a thing and move on with your life.